So now let's play a little bit with histograms. Now histograms at first glance seem very similar to bar plots, but they are in fact doing something slightly different. A bar plot is plotting a different bar for each of a number of different categories. That's why we had to discuss what factors were with the different levels in the previous video. With a histogram, you're not plotting bars for different categories. With a histogram, you're actually dividing up a continuous variable into categories that didn't previously exist. You're taking something that is continuous, a set of measurements, for example, and you're dividing those measurements up so that they're no longer really continuous, but that they are now divided up into these sort of discrete categories that you can then use to visualize a value for each of those, typically the counts. So let's use, again, this EW burials data, but let's use the direction column. This direction column, if you run that, you'll see that it's got a series of values that actually range from 0 to 360. And this is referring to degrees east of north for the orientation of the burials that were excavated in this cemetery. Now, to make a histogram of this, and the reason we're using a histogram now is because we've got direction that we want to plot. And direction is a set of continuous values from 0 to 360. It can be 1.3 degrees east of north. That's a possibility. And so when we run the histogram function and feed it this column, you can see that what results is this nice plot where we've got 1, 2, 3, 4, 5, 6, 7, 8 different bars where we've divided up these measurements from 0 to 360. Here the axis is simply running to 400. But we've divided those up into 8 different groups of measurements, and those groups are called bins, B-I-N. I'll make a note of that here. Now these bins can be changed, right? Because you're taking a continuous variable and you're dividing it up, it's a little bit arbitrary how you do that. There are all sorts of algorithms that you can use in order to calculate kind of an appropriate bin width for your histogram. But you can also just specify arbitrary values if you want, or evenly distributed values. So the way that we do that in R using the hist function is this argument called breaks. Now breaks is a bit tricky to use. You would think at first glance that this refers to the number of different bins that you create. However, if I run this, for example, the hist function as we did before with breaks equal to 10, you'll notice that the plot didn't actually change. We still have 8 bins. And so the breaks is not equivalent to the number of bins that we have. And in fact, what R is doing behind the scenes with this hist function is running a mathematical calculation based on the value that you feed breaks and spitting out kind of an appropriate number of bins of an appropriate width. So what I end up doing a lot of the times when I'm making a histogram, if I don't want to default to some built-in algorithm that they've got, which you certainly can do, there's a whole variety of them, Sturgis and various others, but you can specify a sequence of values. So I know that these data, because we looked at them, run from 0 to 360. So let's say that our breaks are now equal to a sequence using the seq function, it's the seq function, a sequence from 0 to 360. And let's have this, if we were to run it now, the sequence would run from 0 to 360 using increments of 1 to count from 0 to 360. Let's make that 10. So we're now counting from 0 to 360 in units of 10. If we were to use 1 and let it default to that, we would end up with a lot of different bins in our histogram. Now we're going to have fewer bins. So if I run this, we can see that we now have a much nicer looking plot where we can see what's going on with these data a little bit more clearly. Whereas before, if I hit this back arrow here, and click at to see the plot we had before. With only 8 bins, we can kind of get a general sense for what the data look like. But if you divide this up a little bit more fine-grained, you can see with a lot higher resolution what these different values of the direction variable are. You can see that there's really a gap here around 200 and 250, and that there's a lot of values between 0 and 50, more or less. And we couldn't really see with that same level of resolution before. So there's a bit of a balancing act here between capturing all of your data or kind of grouping it very coarsely. So if we were to change our seek argument here in the hist function to 1, this doesn't look nearly as good, right? And now the y-axis only runs to 3 because there are so many single values of the different directions from 0 to 360. So we really want something more in the range of 10, probably, maybe even more. Try 15 or 20 if you would like. And so this is looking pretty good. We can, of course, as with any plotting function, manipulate the X labels, the Y labels. Let's change the X label instead of just saying EW burials $direction. That's not really helpful. Let's have it say degrees east of north. That's more informative. And I don't really like the main title up there, so I will just get rid of that, saying main equals and feed it empty quotes. Now if we run that, we've got a much nicer label on the x-axis. There's no big boldface title at the top of the plot. And of course what we can also do is manipulate the colors in any case. I kind of like the dark orchid color. It's kind of a shade of purple, a little bit bold, but we could use the hex codes to make it transparent if we wanted to, or find a different shade within the same range. There's also another argument that you could use called border, where if you set that equal to false, you'll see that it removes the black lines that were surrounding each bar, and now it's just the color of the bar itself. And so depending on what you like in terms of colors, in terms of whether or not to have a border or not, a lot of this can depend on the data that you're trying to visualize, what you think looks best. You can control all of these different aspects of the plot and add different elements within that hist function using these different arguments that we've learned about.